So adding and subtracting fractions when the denominators are not the same is a little more complicated. We have to find a least common denominator. And so here is a method on how you can find the least common denominator. You can factor the denominators. And this might seem like a long process for numbers, but it'll hopefully connect into what we're going to be doing with polynomials. So 8 factors into 4 and 2, and then 4 factors into 2, 2, and 2. So 8 is the same thing as 2 times 2 times 2. And then 12 factors into 4 and 3, and then 4 is 2 and 2. So 12 is the same thing as 2 times 2 times 3. So when I decide what the least common denominator is, I'm going to make sure that every factor is accounted for. So I need to account for 3 2's. And there's no need for me to, in this separate fraction, add more 3's or multiply more 2's because it's already involved. All that I need in addition is a 3. And so 2 times 2 times 2 times 3 is what? 4 times 6, which is 24. So that makes the least common denominator 24. And so I would multiply this by 3. I would go about my business. I'd add. I'm not going to finish this problem, or I might as well. 29 over 24. So getting the least common denominator can be found by figuring out what all the factors are for each denominator. And that's a process that we're going to use for these fractions. So if they say, let's just practice finding the least common denominator, and you might see it called the least common denominator, or you might see it called the least common multiple. And that would just be if it's not in the context of a denominator. So what's the least common multiple between 3x and 3 times the quantity x minus 2? Well, let's think about it in terms of factors. This first term has 2 factors, a 3 and an x. And this second term has 2 factors, a 3 and an x minus 2. So when I make the least common multiple or least common denominator, if it wasn't a denominator, I need to account for the 3. And there's no need for me to account for it twice because it only shows up one time. And then I need to account for the x, and then I need to account for the quantity x minus 2. So the least common multiple is 3 times x minus 2. If this was a fraction and these were the denominators, it would be the least common denominator. So see if you can come up with the least common multiple between x squared minus 25 and x minus 5. So you can pause the video. So what you need to be in the habit of doing when it comes to the least common denominator or multiple is factoring. So x squared minus 25 can be factored into x plus 5 and x minus 5. And that's going to help me find the least common denominator or multiple, because if you just put x squared minus 25 times x minus 5, you're actually going to have an extra factor in there, and then x minus 5 doesn't factor, so it's just x minus 5. And so when it comes to building the least common multiple, I need the quantity x plus 5. And I need the quantity x minus 5. And then now that the quantity x minus 5 is already included, it's already a part of the least common multiple, so that's the answer, the quantity x plus 5 times the quantity x minus 5. So let's put that into practice here. If I gave you, what number am I on? Number 7 is 3 over x plus 4 plus 1 over x plus 6. Okay. Here's what I want you to do. I want us to come up with a common denominator. And this is the only issue. If you look at those denominators and go, oh, all I need to do is add 2, you're actually wrong. So don't do that. Because if I have a fraction like 1/3, And I just decide to add 2 to the numerator and the denominator. That makes it 3/5. And 1/3 does not equal 3/5. So I can't just add to the numerator and the denominator. What am I allowed to do, though? I am allowed to multiply, because if I multiplied the numerator and the denominator, so if I had 1/3 and I multiplied by 2, then I would get 2/6. And 2/6 does equal 1/3. So I always have to multiply when it comes to getting a common denominator, and that was just a little explanation as to why. And so here's what I have to do. I have to recognize that the first denominator has one factor, x plus 4. So when I go to create the least common multiple or least common denominator, it's gonna have to have the quantity x plus 4. It's gonna need to be accounted for. And then in the second fraction, the denominator is x plus 6. So I need to account for the x plus 6. So the least common denominator is the quantity x plus 4 times the quantity x plus 6. And so I'm gonna put each of those in the denominator. And then I'm going to multiply by whatever I'm missing. So in the first fraction, I'm missing the quantity x plus 6. So I'm going to multiply the numerator and the denominator by the quantity x plus 6. And I'm going to go ahead and multiply the 3, distribute the 3, so I get 3x plus 18. And then in the second fraction, when I decide what am I missing, what do I need to multiply the denominator by, the answer is x plus 4. And so when I distribute a 1, it doesn't change anything, it just becomes x plus 4. And so then for my final answer, I want to write it as one fraction. When I add fractions, now that the denominators are the same, the denominator stays what it is, x plus 4, x plus 6, and then I combine like terms in the numerator. So 3x plus x is 4x, 18 plus 4 is 22. And I think because nothing ends up canceling that they would end up taking this as a final answer, but it's not a bad idea to be in the habit of factoring out the GCF and get 2 times the quantity x plus 11 over x plus 4 times x plus 6. And then just some notation-wise, so either of these should be acceptable. Some notation, I know on the online homework, because it is on big ideas this time, it's going to say that x cannot equal negative 4 and x cannot equal negative 6. And that just goes back to the idea that when you have a fraction, the denominator can't equal 0. So I don't think I have you coming up with that. I just want you to be able to recognize what it means when you see it.